Share my screen. Um, so hey all, welcome to Multimodal Weekly. This is a virtual webinar series hosted by the team at 12 Labs. We've been meeting on a weekly basis over the past, 2.5 years or so, and we tend to cover a variety of different topics, ranging from news research in multimodal AI, foundation models, innovative application of multimodal in different verticals, um, different projects on understanding and multimodal from our community members, and oftentimes guides and application on using our platform and API from internal team members, but also like external developers, partners, etc. These are some sample content from the most recent session. We passed episode 100 recently, which is a big milestone. But you can see like we have talks from AWS. We got talk from like a recent hackathon in advertising in New York. So yeah, a variety of different content has been showcased here on a weekly basis, right? Today, we have three separate presentation from our audience here. So we started out with a research talk from Mina Huh, who's currently a PhD student at UT Austin/UC Berkeley. She will share a variety of different application of multimodal research in assisting people with visual impairments, especially three research work called V2 Coach, GenAssist, and LFVQA. After that, we will have Bhanu Reddy and Manikanta Ravuri. They will present the project called MEMVI, which is a context and memory layer for video agents. So I actually met them during the hackathon in New York, a couple of months ago, and it's really exciting and a cool initiative. So I'd love to learn more about that. And then finally, we close up with a project called Tag from Arush, Siddhant, and Jana, and Vineeth Rajesh. So these folks present an application for social challenge in media where users can record a quick skill, tag a friend to try it, and prove with video. So we also connect with this guy from University of Washington hackathon, in October. It's a really cool and interesting novel application of Pegasus. So excited to hear more about it. So yeah, that's the agenda that we have today for everyone. And quick logistical note for the attendees: if you have any question, feel free to send them on the Zoom chat, and then I'll share them async with the speakers. So with that, I will stop sharing my screen and I pass it to Mina so you can get started.
Okay, let me share my screen and I'll also share the audio. Can you see my slide?
I can see your notes. Yeah.
Interesting. It's weird.
Okay, we can see your slide.
Awesome. Do you see my slides?
Now I'm surely seeing your presenter note.
Huh. Sorry, I checked this earlier, but somehow let's see.
Yeah, make sure you wanna like share your slide, not just the notes.
Hmm. Sorry, this is
Will take a while to like fix this.
let me try one more time. I think I figured it out. Sorry about that.
Mhm.
Okay, I think I figured it out.
Yeah, go for it. You stop sharing just now.
Oh, I don't know why it's like let me sorry, just give me one more second. I'll try it
Um,
one, two more times, and if it doesn't work, I can pass over to someone else to start. I'm sorry,
yes.
I joined early to do the tech check, but I'm using the same.
Hmm. Like if you cannot figure out on your side, then you can send me the slide via email, and I can just like share it on from my side, and then just in case.
Yeah.
Um.
Oh, I think now it works, right?
Okay. Yeah.
Okay. I'm so
Good.
sorry about that. Okay, I can start. Thank you
Yeah.
so much, everyone, for being patient with the tech issues. And thanks, James, for the introduction. I'm very excited to share our research on building proactive assistance for accessible task support. So my name is Mina, and I'm a fourth year PhD student at UT Austin, working with my advisor, Amy Pavel. My research lies in HCI and accessibility, and I have previously interned at Adobe Research and Naver AI. First, to motivate my research, let's reflect on how we communicate in this world today. And visual communication is really the mainstream. So you would upload images to your blog post or share videos on YouTube. But there are more than 2 billion people worldwide who have some forms of visual impairments. And you might wonder how they currently access this visual world. So I will show you some examples. First, this is how a blind person would access online images.
Image. Follow me, a group of penguins on a mission in Antarctica. Penguin stock pictures, royalty-free photos and images.
If you add an alt text to an image, this is read out by a screen reader. And blind people can also access videos with audio descriptions, and here's an example.
Hundreds of animals gather at the bottom of Pride Rock, a tall, flat ledge that towers over the rest of the savannah. Zazu, a small blue bird with a large beak, flaps to the ledge.
So blind people often access the visual world with descriptions, but who's writing them? In the past, this was mainly done by experts, like professional audio describers, and the quality is guaranteed, but it can be very slow and expensive. And to save time and cost, crowd workers have been involved who can quickly provide short answers to blind people's questions. And more recently, AI has really shown the potential to describe the visuals. For example, when we ask ChatGPT about this image on the blog post, it gives us pretty accurate and detailed description. However, real complex tasks involve beyond a simple single-turn question answering and often require consistent assistance. For example, imagine goal-oriented tasks like when you're following a recipe or following a map to reach the destination. You will need visual assistance throughout the steps. In creative tasks, the process is iterative, where you have to review your work, make modifications, and review again. So you will also need to ask a lot of visual questions. However, current AI systems are very reactive, meaning they only provide assistance upon users' request. And this can leave more burden on users who have to keep asking questions, and there might be unnoticed problems. So our goal is to design proactive assistance to support blind people in real-world complex tasks. And in today's talk, I will share 3 projects where we explored proactive support for goal-oriented tasks, in creative tasks, and finally, how we can evaluate proactive AI models. The first project is Vid2Coach, which we presented at WIS 2025. So people watch how-to videos to learn new skills. However, how-to videos are inaccessible. For example, the man in this tutorial video says you can chop it like this, and the narrations miss key visual details like what tool he's using or what shape and size to cut into. And how-to videos also assumes that the person can visually evaluate their progress. For example, here it says, turn off the heat when the butter turns brown, but if you cannot see, it is hard to check the color. So our key idea is to integrate rich information from how-to videos into a camera-based task assistant. And here's the short demo.
Careful, some of your bacon strips are overlapping on the left side of the pan. Try spreading them out so they cook evenly. Great, you have added 3 strips of bacon to the pan, and they are not overlapping. The bacon is still primarily in pink color, so keep going. Great, the bacon is turning into brown. Keep going. You seem to be done because the bacon looks dark brown and crispy. You can also check by feeling its crispiness with a fork or listening to the sizzling sound. Would you like to move on to the next step?
And to design the system, we first observed how accessibility experts provided remote text guidance to blind people. And based on these insights, our Vid2Coach first provides detailed instructions grounded in the video's visuals, which adds clear details to the original narration. Our system also provides tips and workarounds beyond the given how-to video. So when the user is not confident with knives, it retrieves external resources to suggest using the kitchen scissors. And finally, even when the users do not ask questions, it can provide proactive feedback on the progress or mistakes. Then how does Vid2Coach actually work? Taking how-to videos frames and narrations as input, we use an LLM classifier to find sentences relevant for following steps. So here, the greetings or chatters are filtered out. And then we use clip embeddings to find frames. Here, filtering out complete dish shown in the intro, which is not relevant to the current step, or removing a talking head frame. And then with the extracted frames and narrations, we use a large multimodal models to generate high-level instructions like prepare bell peppers, slice 2 bell peppers for toppings. And then also demonstration details that describe how many bell peppers to use, using what tools, and into what sizes. And compared to naively using the state-of-the-art models, our pipeline identified more number of facts than the original video narration, so higher is better here, and also with lower hallucinations, and the lower is better here. And from the instruction generated earlier, we incorporate the user-specific information like vision or their preferences, and use RAG or retrieval augmented generation on external resources that we collected. And this is to get more accessible workarounds that is not always in the original how-to videos. For instance, for low vision users, the tip would be to use a high color contrast cutting board, and for blind people, it would suggest to use a kitchen scissor or chopper. For some tasks like cutting bell peppers, you can actually feel that it's complete by touching them. But if you have to melt butter until brown, obviously you should not touch the burning butter. So we extract the visual criteria from the how-to video. So if there is no butter visible in the pan, it's irrelevant. And if the butter is visible, but it's in the solid form, or if it's started to melt in bright yellow color, then we know that the step is in progress. And when the butter is a golden brown color, then it is complete. And using this criteria as users' progress is streaming, our system classifies the status as irrelevant if the person is washing hands, in progress if the butter has started to melt, and complete if it's brown. And for progress tracking, our approach of using visual criteria actually outperformed models like Clip or Gemini in matching the steps. We also conducted a user study with 8 blind participants, and in the baseline, we let them use any existing approaches, and this is a pretty strong baseline. So they listened to how-to videos to get instructions or used video call for sighted assistance. Here are some examples of VidToCoach providing feedback, proactively or on request.
Great, you're currently mixing the melted butter in the pot. Keep going. You seem to be complete because the butter seems to be fully melted and combined with the egg mixture. You can also check if you notice the mixture has a smooth consistency.
Hey, assistant. Does this look right?
You asked if it looks right. The pancakes in the pan appear to be brown, which indicates they are cooking.
And compared to the baseline, participants using VidToCoach made around 60% less errors in following the steps. So our takeaway in this project is that proactive assistance grounded in task tutorial and accessible resources can offer contextual and adaptive guidance to blind people. In the next project, I will briefly talk about how proactive assistance can help blind people in creative tasks, which move away from following the manuals. And this work, GenAssist, was presented at WIS 2023. So with text-to-image models, people can describe an image in text, and then they can easily generate high-fidelity images. For example, here, we prompted a young chef cooking dinner for his parents and got 4 diverse images. However, when blind people used these tools, they had many questions about the results to decide which one to use. So for example, one blind person generated this 4 images with the prompt, a middle-aged woman at a desk, and she's looking at the screen. But they first had questions of how the generated images are different from each other. And then they also wanted to verify whether the images actually followed the prompt, because that is always not always the case. Here, the prompt says she's looking at the screen, but when we look at the images, they're all looking at the camera instead. And they also asked about the style of images, whether they're illustrations or photos, and if there's any distortion errors. And finally, they asked about the appropriate context, whether the images would look good for the usage. And while they asked many questions about the results, it was very difficult to remember and access all the information, especially when you're remembering information about multiple images. So our key idea is to predict relevant visual questions that blind people would ask in creation and summarize answers for comparing these results. And we use this framework that first predicts relevant visual questions given the user images and prompts, and then we generate answers for individual images, and finally summarize them into a single response. Let's look at an example. So first, from the user prompt, we use an LLM to generate prompt verification questions. So if the prompt is about a young chef cooking the dinner for its parents, we would ask questions of whether there's actually a young chef or if he's cooking or not. And then we generate answers to these questions using a VQA model. And finally, we summarize all this information again using an LLM. So GenAssist uses a table format to provide visual information across images so that screen reader users can selectively access different types of visual information by reading a row and also access individual image information by reading a column. So our takeaway from this work is that proactive assistants that predict and summarize relevant visual information can help blind users to verify and compare generative AI outputs. And this final project, Long-Form VQA, was presented at Colm 2024. And here we explored how to evaluate the vision language models that are proactive by default. So let's look at an example question and photo uploaded by a blind person. So for this question, what is this? Traditional VQA models aim to generate this short answer that it's a soy milk. However, if you ask the same question to ChatGPT, recent vision language models are capable of generating longer answers, like this example. So it describes that it is the Silk brand chocolate soy milk, also tells about its calories, it's 8 fluid ounces. So much more information than what is asked, proactively sharing all information. Then what is actually contained in these long-form answers? We identified 8 functional roles of sentences, which I will go over in the coming slides. So we'll look at this example long answers to the question, what is in this bottle? The first sentence is confirming what the user has uploaded, saying that it shows a bottle with a label that says mustard. And sentences with answer roles directly answer the question, here describing that it is a mustard sauce. And explanation role says its reasoning is because of the colors. And auxiliary information roles provide information not directly asked in the question. For example, here, it explains that the mustard dressings can be used for salads. And finally, suggestion sentences often appear at the end, asking users to provide a better photo or asking if users need additional assistance. And using these functional roles, we built a classifier and then we analyzed the state-of-the-art vision language models. And this graph shows that their long answers really contain information, diverse information beyond just answers. Traditional benchmarks for VQA focuses on the single short answer. But future evaluation should consider diverse roles and also evaluate beyond accuracy, like how relevant the information is or how redundant the answer is. So our takeaway from this final project is that proactive AI models, they give long-form answers which contain diverse information beyond visual information. And now we need more comprehensive evaluation with end users beyond accuracy. So in today's talk, I shared our works on proactive support for goal-oriented tasks, also proactive support for creative tasks, and finally on how we should evaluate this proactive AI assistance. And future work can explore personalized assistance with the context of users' background knowledge, skills, and preferences so that the assistant better knows when to be proactive depending on different individuals. So thank you for listening, and I'm happy to answer any questions.
Amazing. Thanks, Mina. I think this is a extremely impactful, research project that have a direct social impact. Also, a cool application of multimodal understanding, right? Maybe like we can have like 1 or 2 questions before we move to next presenters. yeah, the audience, if you have any question, feel free to just put on the chat. And so when you said in the future you had personalized assistant based on knowledge, skill, and preferences, in order to make that happen, do we have to like what could be some of the improvement like for the existing pipeline that you kind of think about, like both from a model's capability, but also from the like the design of the of the pipeline and the data ingestion, the signal as well.
Oh, so your question is on like, oh, how we can change these pipelines to be more adapted to like more to
Person-
provide more personalized support?
Yeah. Yep.
Yeah, great question. I think like over the course of interactions with human users, I think the system can learn what kind of information that they value, like when they ask questions or when they pause the assistant from giving guidance. So for instance, in the project GenAssist, when we did the user study, we learned that some people really care a lot about colors or image styles. Whereas other people just cared about like what's on the content. So like different people have different like priority of what information they want to know at different moments. And for Vid to Coach, depending on people's skills, so if they're very familiar with the recipe that they're currently following, they have made pasta for many times and just need very high level guidance, if the system can model that and from the past experiences, then we would not need like that frequent active guidance. So I think that can be learned over the interactions of users and what questions they ask.
I see. Yeah. Um,
Mina, can I ask a question? I'm not sure if you can hear me. It's pretty loud where I am. Um, can you elaborate on the vid to coach? Is it mostly like an abstraction over a vision language model, or is it a model on its own that's able to sort of proactively um, like um, give suggestion given a prompt?
Oh, sorry, was your question on like specific project? I think your like the beginning of your question was kind of cut off.
Yeah, I'm asking about vid to coach. I'm
Uh-huh.
asking whether that's an abstraction over a vision language model, or is it your own model that's able to sort of proactively um, infer given like some real-time inputs?
Oh, so you're asking if we used our own models or like used existing vision language models to provide those guidance. So we built on top of like both Gemini's like live streaming vision language models and also batch model. So we designed this like additional layer of pipeline that abstracts like different visual criteria and do comparison like matching with like users egocentric stream, but we're building on top of like the Gemini model.
Thank you. That makes sense.
Thank you.
okay. Yeah, I think probably due to like time constraint, I think that's all the question that we can have. Thanks again, Mina, for preparing the materials and walk through these three exciting work. Oh, maybe one final. So uh you on the application side, right? And I know you like kind of wrapping up your PhD in this domain and probably think about like kind of industry application of your research work. What are some of the you know use cases or industry that you think could benefit a lot from this kind of AI power creativity support tools that you've been focusing throughout your PhD?
Oh, you mean like how we can have like impact on industry tools,
Yeah.
like the takeaways from our I think while our systems like here we talked about like the target users as blind people, but a lot of the features that we have could also be useful for like just general audience. So for instance, like GenAssist, it kind of supports like verification of generated images to your prompt, like your intent, and then it supports comparison. So I can also think of like, oh, industry tools when we generate like a large batch of images and we want to like select the ones that actually are faithful to the prompt, or when we want to understand the differences, then it could also be useful for those batch creation. And for vid to coach, we're already seeing a lot of like Meta Ray-Ban glasses, like smart glasses are becoming more common. So I can also see like, oh, it being useful for like in our daily like uses.
Nice. Awesome. Looking forward to see those application of your research in the real world.
Thank you.
Awesome. Thanks, Mina. Yeah, Bhanu and Manikanta, do you guys want to go ahead? Get started.
Yeah, let me share my screen. Please let me know if you guys can see my screen.
Yep, I can see it. Big must slide.
Perfect. All right. Hi, everyone. I'm Bhanu, one of the founders of Memby.ai. And before we jump in, I want to introduce my co-worker, Mani.
Hi everyone. Man, born or building memory for the past 2 months after the hackathon from BetaWorks.
Okay, so I will give you a context before we kickstart this thing. The two of us went to BetaWorks in New York for 12 Labs hackathon, and that's where we spent a weekend trying to push the limits of what multimodal agents actually can do. And the deeper we went, it was more clear for us that there was a fundamental piece missing in the AI stack, and that we can turn into a much bigger mission. And today we are building Memby.ai, the contextual memory layer for multimodal agent. Let me show you why this matters. Okay, so when we started building multimodal agents that could work across different modalities of data, be it text, images, and video, we noticed something surprising. The models were powerful. They could interpret anything in that moment, but none of that understanding persisted. There was no continuity in place, no place for context to live, and no memory that was carried across different modalities or time. And all of this became even more obvious when we look at how agents operate today. They don't carry any state from one interaction to the next. They lose context instantly, even when that context is critical. That can't remember prior interactions properly, and they can't build long-term understanding or improve over time. And the result is what we call operational amnesia. Agents experience every task like it's the first time. And here is why solving memory matters right now. Can you imagine 80% of the world's data today is video? The rich, dense, multimodal information that agents should be learning from, but they can't retain that. And almost 90% of this data was created in the last few years. So we are dealing with an unprecedented explosion of multimodal information that's growing faster than our tools can handle. This shift demands a memory layer that can keep up across time, different modalities, and across different tasks. So we are on track to see more than 1.3 billion AI agents deployed by 2028. Again, this is a very conservative approach by Internet Data Center, IDC. That's the entire population of China, just for your context. But here's the thing. Every one of those agents will require a way to remember, to understand, and build on past interactions across text, images, and especially videos. So the demand for contextual memory isn't just increasing, it's compounding. And that's exactly where memory fits into equation. So video is the most perspective dependent modality we have. Let me tell you why. So consider a 30-second video clip of a person going to a jewelry store. It can mean completely different things depending on who is looking at it. A marketing agent can see it as a customer intent. A security agent can see a suspicious behavior. A training agent can see it as a coaching opportunity. And an operation agent can see it as a workflow inefficiency. So each perspective is valid, but none of them is complete. And the real problem is, ask those same agents about that same video tomorrow with the same question, and they will remember nothing. So this is the core challenge of video AI today. And it's not of lack of intelligence, but absence of memory layer. So what makes MEMV different is that it's built truly on multimodal data from day one. We don't store text, we capture and connect different knowledge across different modalities of data as soon as your agent interacts with. And then we turn that into real-time semantic memory graphs that agents can instantly use. So this means agents can finally retain all the tribal and institutional knowledge, recall past interactions, and build on top of what they have already learned. Also, we cleanly integrate with existing LLMs, agent frameworks, agent runtimes, powering the entire autonomous workflows and scaling all the way for enterprise use cases. Again, all this without locking into one vendor ecosystem. So at its core, MEMV is the universal infrastructure layer for multimodal agents. So one of the most exciting part of building a true multimodal memory layer is how broadly it applies to different use cases. Personal companion robots can friendly, remember your routines, preferences, and past interactions. AI glasses and wearables can understand what you have seen, not just what you have said, right? Contextual assistants can maintain that continuity across days or weeks instead of minutes. And inside enterprises, agents can preserve tribal knowledge. That's usually when a lot of teams or people leave from the company. And these are just only a set of examples. We are seeing new use cases emerging almost every week. So here's a high-level diagram of how MEMV works. At the top, you can see that we have the experience layer wherein our apps and agents can connect through our API and SDK, giving them that real-time working memory option. And we can play around with memory modification APIs. You can add, update, and retrieve knowledge instantly. And below that is the contextual layer where we try to unify everything, be it a document, vector, video, audio, or graphs, all are connected into one layer, and it creates a semantic memory fabric. And beneath that, MEMV ties directly into the enterprise data. So agents aren't like guessing and hallucinating. They operate with real business context from day one. On the right-hand side, if you see, we have the LLMs, state-of-the-art LLMs. That's where we are using 12 Labs, Marango, and Pegasus models. And apart from that, we have our own custom fine-tuned models too, VLM models too. And then we don't have any lock-in over here. And the result is an end-to-end memory engine. You can process your content once, we index it all, we remember it, and then serve it back instantly to you. We do all the heavy lifting so that you can build multi-model AI applications, not in months. You can spin it off right in hours. It's very straightforward approach. All right, over to you, Mani, for demo. Thanks.
Thank you, Bhanu. James, I think I need access from your end to present. Okay, yeah, now I can.
Yeah, I think you should go.
Guys, can you see my screen?
Yeah, I can see it.
Yeah, okay. This is the application we are building. So as you can see here, like we already created some spaces beforehand, so it won't take much time for the processing. Anyway, I will just do a live one. So by the time it is happening, we can just
No,
go
no,
through
no.
others
I
in the
think I
background.
think you are not sharing your screen, Manny. It's my screen that was being shared.
No,
Oh,
I'm
okay,
seeing
okay.
I'm seeing
Okay.
Mani.
Sorry,
Yeah.
sorry about that. Go ahead, Manny. Sorry to cut you short.
Yeah. So I can just name it as we have just created a space and we can start by uploading a video. This is the video same. We already have it indexed and I have a graph created for that. So what we are generally doing is like once you upload the video, then we will be processing it with different providers. So right now we are using Marango with the S3. So we have to upload it to S3 and we are similarly like we are uploading it to 3, 4 multiple places for saving it and processing it with different LLMs. Mhm. Okay, it is uploaded now, so we can move forward with the demo. So as you can see here, like the test lab is the one we created just now and it is still in processing. So I will go with the ones that are already created for this demo. So this is how the graph will be populated once the video is processed, and then we can start querying on that, or then we can go ahead and add new memories to it, or we can invalidate the existing ones as well. If you can see here, it has the sources like from where it got this data, and there is some user input as well, because just for the purpose, I've added some information which we can cross verify. I'll just fire a query and we can see how it is giving the responses and all.
Sorry, what are the nodes here?
So the nodes are like the objects. For example, let's say during, I will just start with a simple one so we can understand it, and then we can jump back to this one. Yeah, for example, if you see this one, like when I created a simple user, then it will just say the user, and then I can start adding it more data to that. So over time, it will build that graph. Then we can query on top of it and always get the factual information. For example, if I ask it like, yeah, so it will get the data with the reference as well, like money is building the MB and all these things. And also we can ask like who is the co-founder. Yeah, so it will just go to like say Bhanu is the co-founder and together they are building the MB. And we can add a live example. For example, we just said here like we are preparing for a presentation. I will just go ahead and add. So once the memory is added, like it will go through the LLM and it will take some times to reflect in here. We can get back to this one in the meantime. Yeah. So these nodes and edges are just like the entities and relations between them. Even if we just load this. Okay, so once I find that one, yeah, as you can see here, like it said, we are the user is presenting demo to 12 labs and it is hosted by James Lee. So then when I go back and start asking the questions, it will find those references from there.
So to answer your question, we are creating memories on the fly, and the moment, like if there is any real time information that you want to add to your memory layer, you can add it. So right now, the way Mani is demonstrating is we are taking all the information that our VLM models are getting out of the videos that we are uploading and then creating a memory graph. So this memory is something that's tracking based on whatever the information you are providing. And also it has the capability wherein you can add external documents or whatever your institutional material is. And you can
Yeah,
query on top of that.
yeah, or if you feel some information there, like VLM interpreted it wrongly, you can just invalidate that, or you can correct it by saying the right data. So, okay, as you can see, like as I start asking the questions, it will pull those references, like we are present into the 12 labs hosted by James Lee. And if you go to the video library, we can see that the space where we have created the test live one, the video is ready, and then we can just go ahead and query this one as well. Yeah, this is the graph that is created based on the information that got interpreted from the video that we have uploaded. And then we can just start asking the questions, or we can add new data to this one or invalidate anything that is already there. And also, we are also building like a Python package. So if you want to use that memory with the agents, you can just simply create a API key, then use our Python library and start building anything you want on top of that. And currently we are focused, like the work in progress is on integration. So because the video data is really heavy, most of the times users will be having it some cloud storage or Google Drive or any other storages. So we are creating this integration so it will be easier for them to get their data into our platform. Yeah.
We can fire a bunch of questions, Mani, from the video that we uploaded.
Yeah.
Wherein we can showcase different kinds of memory, episodic, semantic, temporal, and all that.
Yeah, maybe like one or two more questions.
Yeah.
Yeah.
Then we can.
You want to fire any question?
Take the creative liberty, please.
Yeah. Or we can also try firing a question, and if the data is not available, we can add that and then query it, so we can see how it is working. Okay, it says it currently doesn't have the person's name, so it may not be brought up in the video. Then we can just go and try to add that in the one. We can just say, okay, it has created that. Then we can just go and. Yeah, as you can see here, it will just say like the one who is talking is Bhanu. Yeah.
All right.
Thank you.
Thanks, everyone.
Yeah.
Yep. Very cool and on nice demo and great UX UI design as well. If you guys have any more question for Bhanu and Mani, feel free to ask on the Zoom chat and they can answer, I believe. Maybe will be like available to play around in the next
and
couple
also we forgot to mention right now we are doing a wait list, and over the Christmas we will be sending out invites as well.
Awesome. That's great. Due to time constraint, I do want to move to the final group.
Yeah.
So yeah, Vineeth, Arush, and Siddhant, do you guys want to go ahead and start presenting? We're probably gonna go over for a little bit, but yeah, take your time.
Sounds good. Let me start screen sharing. Do you guys see the screen?
Yep, that's it.
All right. So today we're going to be presenting a mobile app that called Tag. My name's Siddhant, and I'm going to be presenting with Arush and Vineeth. Unfortunately, our them couldn't make it today. This is a mobile app that we created at a hackathon called Dub Hacks, and we are all freshmen at the University of Washington. Let's get into it.
Hi everyone. So our project is called Tagged, and the whole idea is that you have to rethink how people learn new skills. A lot of the time, learning feels super individual. You watch videos alone, you practice alone, and it's really easy to lose motivation. Tag tries to fix that by creating an inclusive space where people can actually share their progress, connect with others who are learning the same things, and even have some friendly competition. So overall, the goal is to build a global community where learning feels fun, social, and supportive instead of just isolating.
Sorry, took me a second to unmute. Some of the key features of Tag, the first one is that they're skill-based communities. So at Tag, we want to foster dynamic communities where users can connect and collaborate, enhancing their learning experience through shared interests, skill development, and ultimately driving engagement and motivation. So what those communities can look like, it can be anywhere from a small group of friends to a citywide music group. Different categories can be like sports, music, etc. And in the app, you can make either private groups, again, just with local people that you know, as well as public communities where anyone is free to join in or exit whenever they like. The second main feature is the video learning. Whenever users are able to learn a skill, they post it up for the community for either individual communities to see or in an explore tab where you can explore different communities, see what people in the local area are learning, or you can see again globally just around you what skills people are learning. Now let's move on to a demo of how our app actually works.
Yeah, so this is the explore page. So it's sort of modeled after TikTok. So you sort of scroll up and down and you can comment as well. So this is just a video of me playing the guitar and I've tagged Sid. So basically now, uh, okay, the comments, and I guess he's making a comment. Yeah. And then this is the communities page. So you can go to different, oh wait, he's recording a video. Um, Yeah, so the whole software here is that there's a video verification system. So basically what it does is it does a API call to Google Gemini, or sorry, 12 Labs. And 12 Labs basically makes sure from the context of the video and whatever description you put, it makes sure that you're actually doing the video. So the whole point is that you can't just cheat and you can't just like let's say for example, I play a really hard song on guitar and I just in the actual video I'm just playing Twinkle Twinkle Little Star. Like you can't do that. It'll know. And then of course everything is saved to Amazon S3. So the all everything will be stored, like that kind of sign-in data and the video data. So you can, you know, create accounts and such. And yeah, so he's going to the account that he just tagged. So he's trying to sign in, yeah. And this is the account that was just tagged. And so now in the inbox, if he goes to it, okay, well, when he goes to the inbox here, Yeah, this is the explore page again. But you should go to the inbox soon. Yeah, so the inbox is where the tag requests will sit. So basically, when somebody tags you, it'll show up in the inbox. And now you have a certain amount of time to respond. And again, same video verification software, it makes sure that you're doing whatever the tag is. And basically, you're creating these sort of tag chains. So a friend will tag you, and then now you're going to tag your friend, and so on. And that's sort of how you learn the skill, right? So that's just sort of a friendly competition way to just learn the skill. And yeah. As you can see here, it shows up on the explore page. So all tags will show up in the explore page, but we only had a few demo videos, so the explore page is pretty short. But as we populate it, the explore page will get bigger.
Yeah, and then just to reiterate on, again, our use of 12 labs. So using 12 labs in our application, we were able to automate the skill verification using 12 labs. Again, the API call that Arush was just mentioning. It uses a multimodal analysis, taking in both vision, audio, motion, all to be able to verify this. So again, like Arush was saying, if they play a different song, the audio is going to be able to recognize that the song is different. If it's a more visual based skill, say with the person doing the flip, if they're just, I don't know, laying down, again, it's going to be able to catch that and then block it off. Again, just doing some basic moderation to ensure that whatever skills the person is claiming that they're able to do is, again, on some level accurate in the video. And then going into some more detail, it creates a confidence similarity score to validate or reject submissions. And then back to the actual app, this ensures that there's fair point distributions within the different users as people learn skills, and then creating some level of accuracy within the leaderboards within communities. And then the other benefit from like a back end point of view is that it minimizes manual review again, rather than having actual people go in or the communities themselves having to review it, is going to be able to prevent um, people from inaccurately uploading videos, and this can be scaled to thousands of videos. And another benefit of this is that it'll prevent any scam videos from like overpopulating the app or overpopulating communities just with junk videos. And then in the end, it delivers fast, trustworthy verification that keeps the overall user experience high quality.
All right. So this slide is about where 12 Labs is headed and why that matters for tag. On the left, you see things 12 Labs is already used for today, like video search, action detection, tagging, and content moderation. Those are the standard industry applications. But I think the exciting part is the future. 12 Labs is moving towards deeper understandings of skills, things like personalized skill recommendations, auto-generated tags and difficulty scores, real-time technique analysis, and even automatic highlight reels that track your progress. It can also support smarter moderation and let users search inside videos for specific moments. So instead of just recognizing what's happening in a video, 12 Labs is starting to understand how well it's happening. And that opens up a ton of possibilities for tag.
Thank you everyone for giving us the time. Again, here are some of our contacts. But again, if there are any questions, please feel free to ask.
Awesome. Thanks, Guy. We're running a bit over time, so probably not time for question, but yeah, like it's a really interesting and novel application about technology, especially for the like social context challenges, right? Um, and to some of your point, right, like about future use, I think um, better personalization, real-time feedback analysis, all those things are um like good help I guess like push the limit, right, about models and the kind of answer that the model returns will help us like improve model performance better from a training and like inference perspective, right? So I'm always like really excited to see like novel use cases like this. that can help improve the way we build the models, right? To become better. Yeah. Also, I think it's like the first time like I saw like a mobile application that being used with Labs. So I think that experience is also very interesting. And yeah, hopefully we can next year we can like think about like demo apps or like small, prototype right on the mobile device to see how video understanding can operate in that environment. All right, guys. Appreciate the time spending today. Thanks all the speakers who are still remaining on the session. Three very exciting talk, right? From the research point of view to like the context memory point of view to like an interesting application about model. The recording of this session should be available on YouTube probably by early next week, and we'll have more like content for the webinar series, before the year end. So if you found this content valuable, then yeah, please stay in touch and follow up and check out future session.
Thank you, James. Bye, all.
Thank
Yep.
you, James.
Thank you, James.
All right, thanks, guys. Appreciate it. Cheers.